video we are going to discuss about capacitor. But before we start deeply about capacitor, I request to subscribe so that you can see the update video that we will keep uploading in this playlist. So the previous video we have discussed when we were talking about resistor. You know that resistor, we already discussed about the resistor. Now we'll talk about another component we call a capacitor. What is first a capacitor? A capacitor, as the name say, capacity, come from the capacity of what? Capacity of storage, to store energy. Mean that a capacitor is an electrical device that is to store energy. This to store energy. How can store energy? Let's see how a capacitor is made. A capacitor is made by two plates. Let's say these two plates, and we have another plate. These are separated with a distance d, and this area, it has a dielectric field. Dielectric material. Now, in these two conductor has area A. Means that these two conductor, we have two conductor which are separated with a distance d, where it's filled by a dielectric material, so it will form a capacitor. Now this capacitor will store energy inside. It will store energy, electric energy. Now this capacitor, how it has a constant called capacitance. Now the capacitance, to determine the capacitance, we have C equal epsilon A divided by D. This one is the electric material, the permittivity, and we have the area. This one is the area, and we have the distance separate the conductor. This distance d. Now if the distance, we know if the distance is small, this capacitor will be high. If the distance is big, this one will be small, as we see. Means that we can vary the capacitance of a capacitor by varying the area of the plug, or the permittivity, means that the material, or the distance between the two conductor. Now that is one formula how to determine the capacitance in a capacitor. Now these two plugs, it has their charge. They have charge. We have this one is charged positive. First is charged positive charge. The other charge negative. Mean that if this we will have a difference of potential. We already see in the previous video that when we have positive charge and a negative charge, we will have a difference of potential. And when we have difference of potential, what's this? That is the voltage, that will directly have a voltage. Now it means that when we have a capacitor, the capacitor, it will have a voltage. Why? Because there is a difference of potential, difference of charge, positive and charge negative. As we see, we already see, we'll have one charge with positive, the other charge the other it will be negative from other plane. Mean that these two are separated with distance d, so they will have a difference of potential. Why? Because I have two different charges. Difference of potential. And we know that if we have difference of potential, what's this? Voltage. Now, a capacitor always have voltage. When it will have a current will be strong. Now, in our electric circuit, we can present our capacitor as this way. This one we have the capacitor. This show the conductor of the plate. Now we have this capacitor. The current will flow from to enter in this capacitor. Now, if current is entering this capacitor, we'll have a voltage, a difference of potential. Why? Because I will have positive charge and negative charge. And now I have to find the relation between this voltage and this current and the capacitance. The capacitance. Now, since current is charging, is entering the capacitor, they will have a charge Q charge. This charge Q is going to be equal to C multiplied by V. Meaning that the charge entering in this capacitor is equal to the capacitance multiplied by the voltage. Or I can say that the capacitance is equal to the charge Q divided by the voltage. When I have the charge Q that's entering in this capacitor and the voltage, I can determine the capacitor. I can directly determine the capacitance of the capacitor. Let's see some physical example, some of the component how it look like in the practical. Now we will see that this one we have this one are the capacitor. All are capacitor that use. We say that capacitor used to store energy. Are used in, let's say, in computer devices. We used to see sometime when a component or when equipment is off, it will still on working. It will still working in some time. Why? Because there are some capacitor which has store energy, and when the device is off, it will release this energy that I have stored from the capacitor to work the device. So this one are the some practical example of capacitor. Now the unity of capacitor. The unity is made by farad or microfarad or RCM unity. Farad or microfarad. Now, what is? Let's see the relation between the voltage, the currents, and the capacitors. We already see that when we have this capacitor, the currents entering E, and we have positive charge here, we have negative charge here, and that will have a difference of potential. We have voltage V, and we have the capacitance C. Mean that the current ET is going to be C divided by T, derivative of T, of Vt divided by dt. That's the formula, the relation between the currents flowing in the capacitor and the voltage with and the capacitance. Now, the current that's flowing in this capacitor equal the capacitance multiplied by the derivative of the voltage divided by T. Now let's see from this formula. What this formula say? The formula says that we'll analyze that if V is constant, So mean that the E is going to be 0. Why? Because derivative of constants is going to be 0. C multiplied by 0, I will have E. And we see in the first video that when E is 0, when there is no current, it will be open circuit. Open circuit. Why? Because the current will be 0. Mean that in DC, because the DC, the current and the voltage are not dependent on time, the capacitor in DC analyzes the capacitor act as open circuit. Open circuit. Why? We already see, because in DC V is constant. When V is constant, it will be 0, so it's going to be open circuit. Now, if from this formula, if I want to determine the voltage across the capacitor, I will determine Vt is going to be equal, from this formula, 1 by C integration of 1 by C integration of dV t divided by integration divided by dt. Now, no, it's not like that. It's going to be it's not going to be like this one. It's going to be, we'll have V equal 1 by C. Why? Because I want to find V, I will have dV equal I multiplied by D divided by C. So I'll have 1 by C integration of I t divided by dt. This one, the formula that we are going to use. How do we determine this one? When we have this one, I will have dV C dV equal I multiplied by IT multiplied by dt. Mean that if I want to find dVt, I will have 1 by C. And finally, when we want to remove this derivative, we will find directly from, we'll remove the derivative by integration. Now, this one go from, we're going to do, since it is integration, from T0, from T0 to T. Since it's going to have from T0, directly I will have plus Vt0. Why? Because the capacitor can have voltage at T initially. Let's say, for example, my capacitor can have voltage initially before the current start flowing. When it's at T equals 0, it has a voltage that I have to add them. That's why I add plus Vt0. This one is Vt0. This one plus Vt0. Now, let's see some example. We have this one. It said that calculate the charge stored on 3 picofarad capacitor with voltage. Now, I will say that to give me the voltage 20 volt. The voltage across the capacitor. I have the capacitor C. I have the voltage that's across the capacitor. I want to find C equal 3 picofarad. I want to find the charge. I know from that formula that Q equal CV. The charge stored from this capacitor is going to be the capacitance multiplied by the voltage. I'm going to have 3 multiplied by 10 power 12 multiplied by voltage 20 volt. I will have the charge. Now why multiply by minus 12? Because it is pico. If I want to save my charge in ampere, I will convert it to pico. If I maintain the pico, 3 multiplied by 20, I will have 16 pico ampere. I will keep the pico. Why? Because this one voltage, the voltage is in its own unit, initial unit. Now I already found the charge Q. Now found the energy store. I have that E equals C dV by dt, and I know that power equal the voltage multiplied by the currents, as we see in the previous video. Now if I take the currents, what's the currents? C multiplied by V multiplied by V dV divided by dt. This one is going to be my power. C dV by dt, this one my current multiplied by the voltage. Now I have the power. I know from the power that energy equal integration of power with respect of t. So I will have integration of C V dV dt with respect of dt. Meaning this dt and this dt will go out. Now finally I will have integration of CV dV. Now integration of C is constant. Since C is constant, I can bring to go out. I will have finally integration of V dV. If I say integration, I will have C energy. I will have C integration of V dV. Integration of V dV. This one is going to be 1 by 2 C V square. Why? The C integration of V dV is 1 by 2 V square multiplied by the C. Now I already know the formula, one formula of the energy. The formula of energy, I know the formula now for energy. Formula of energy, I will have energy equal 1 by 2 C V square. That's the formula to determine the energy. The energy stored in the capacitor, because in the beginning we say that it is named capacitor because it has the capacity to store energy. Now it is the formula how to determine the energy stored in that capacitor. Now this energy from this question, the capacitance is known 3 picofarad. So I'll have 1 by 2 multiplied by 3 multiplied by V. What's this? V is 20. V is 20 square multiplied by 20 square. Now if I maintain, I do not change the picofarad, mean that I will have picojoule as my energy. But if you convert this 3 pico to farad, I will have joule as my energy. Let's see another example how to determine. We already see the relation between the voltage, the current, the capacitance. We see how to determine the power in a capacitor. We see how to determine the energy stored in a capacitor. Now let's see another example. Now this capacitor, you say what is the voltage across? I have the capacitor. across 4.4. I have C, this one the capacitance, 4.5 microfarad. Now I want to find if the charge on one plate is 0.12 charge Q, 0.12 microcoulomb. How much energy? Now I want to find the energy. We already see all the formula. What's the formula? I know the formula of energy. Energy equals omega equal 1 by 2 CV square. Is it how to solve the exercises? First to know the formula. So that when I already know the formula, which one I don't have? I have the C. I don't have the V, the voltage. Now, how can I determine the voltage? Oh, I know the formula. Q equal CV. Now, if I want to find the V, is going to be equal Q divided by C. Q, I have the charge, it's already given. C, I have the capacitor. Now, it's easy for me to determine the voltage. When I already determine the voltage, I can directly come here to determine the energy. Now, we have to be careful from the unity, because the charge, it is micro coulomb. The capacitor is, the charge is millicoulomb, and the capacitor is microcoulomb. Mean that either I converted this one to millifarad, so that I will have milli and milli, or I converted this one to microcoulomb, so that I have micro and micro. Which one you have to choose, so that I can maintain the voltage in 1 unit volt, and put here the energy to be in joule. Either you have this one multiplied by 10 minus 3, or you have this one, you convert this one. Is it how we can solve this, determine the energy? Now let's see another example so that we can finalize in this topic. Now if we see this example, the voltage across the capacitor is given. I have the voltage, I have the capacitor, I have the voltage Vt equal 10 cos 6000 T, and you give me the capacitance equal 5 microfarad. Now you told me to determine the current IT. We already see the formula how to determine. We know the relation between the currents and the voltage, C divided by dt. Now I have the C. What's the capacitor? Capacitance is 5. This unit is volt, and that I can maintain this micro, so that my current will be microampere. So I will have 5 derivative with respect of t of the voltage. What's the voltage? 10 cos 6000 T. I just replace the voltage. The voltage is this one, 10 cos this one. So derivative with respect of t of the voltage, this one my voltage, I replace. I have this 5. Now I will have 5. What's the derivative of this one? If I have this one, I will have sine cos minus sine minus cos. This will be my derivative sense, derivative direction. Mean that derivative of cos is going to be minus sine. Derivative of minus sine is going to be minus cos, and etc. Now derivative of cos is going to be minus sine. So I will have 5 multiplied by 10. 5 multiplied by 10 this time, because this thing already constant can be here, multiplied by this negative is nothing, multiplied by 6000 sine 6000 t. Don't forget this minus. We'll put this minus here. Unity, since I save the capacitor in microfarad, I will have microampere as the unity of the current. Now, first of all, you have to know the formula. When you already know the formula, you know the second table how to manipulate them. But before, if you don't know the formula, it will be difficult to manipulate and to solve the exercises or the question. Let's see another example also. As we see in the previous one, we discussed that when in DC, capacitor acts as open circuit. We see, and we just matter why. Now, let's see another example. We have to know this remark, this hint. Now, let's see another example. This example, he said that determine the current through this one with voltage. He gave me the voltage. He told me to determine the currents. Now I have to know that current ET equals C dVt divided by T. The C I already have 200 microfarads. The voltage I already given here. Now I have to find the I. But if you look at my voltage is with interval, is not constant. It's vary from 0 to 1, from 0 t to 1. What is the voltage? The voltage is equal 50t. In that I will have IT is going to by C 200 multiplied derivative with respect of t of the voltage. The voltage is 50t. So I will have 200 multiplied by derivative of 50t is going to be multiplied by 50. Derivative is going to be 200 multiplied by this one. So I will have IT finally equal 200 multiplied by 50. I will finally have 10 power 4. But the unity, the voltage in volt, the capacitor in micro, I will have microampere. Now, even if it did not give you this one, let's say consider it did not give you, but from you, it can give you directly this graph. From the previous video, you have to determine the voltage to come as this writing. Now, from 1 second to 2 seconds, from 1 to 2 seconds. Now let's see, from 1 to 2 seconds is the same graph from 2 to 3. So in that case, no need for me to put the 3. I can go directly from 1 to 3, as we see in the previous video. So before we come to this video, I request to go and see the previous video where we discussed the relation between charge and currents for better understanding, because we discussed how to solve when a graph is come like this one. Now from 1 to 3, what's the graph? 100. So I'll have IT is going to be C 200 multiplied by derivative with respect of t. What's the voltage? 100 minus 50 t. Now when you derivative of this one, you will get the currents. Less derivative of constant is 0, so it's going to be 200 multiplied by minus 50. So it's going to be minus 10 power 4 microampere. Now let's see from 3 to 4. From 3 to 4, from 3 to 4, from 3 to 4, what's the graph? You can determine, we already see, but now he give you minus 200 plus 50. So just to put minus 200 plus 50, minus 200 plus 50. This case is 0. So I will have minus, I will have I equal 200 multiplied by derivative, this one minus 200, not minus 200, plus 50. Finally, this one is going to be 0, so it's a constant. Finally, I will have 200 multiplied by 50. It's going to be 10 power 4 microampere. Now I already found. This means, how can I draw the graph? To draw the graph, if I want to draw the graph, I don't want to go to another page so that I will not lose the value. Now, if I want to draw the graph, from 0 to 1, from 0, 1, 2, 3, 4. From 0 to 1, I have 10 power 4. So I will have 10 power 4 here. From 0 to I will have 10 power 4. This one. From 1 to 3, from 1 to 3, I have minus 10 power 4 here. From 3 to 4, I have 10 power 4 again here. This one my graph of the currents, but in microampere. Why? Because I maintain the capacitor. So how can we determine the relation between the capacitance, the charge, the current, and the voltage?